Yeah, we are in day 5, 261 days down to the gate 2027. So previously we have seen 262 day 4, which we have said about Raoult's law. Now what we are talking about in this today's learning. Let us talk about something called first order kinetics. You can see the directly, first order reaction. Let me not say kinetics, it's a big word. See, generally, when we are looking at such particular concepts, this comes under well-known subject in our chemical engineering, that is known as chemical reaction engineering. This is given as, you can see minus RA is equal to K into CA. See, be very specific here, which is capital letter, which is small letter, because that deviates, or rather, if we are unable to catch that, we will get confused with the capital letter and a small letter notation scheme. Okay, right. See, as it is, I said minus RA is equal to K into CA. See, there are, as it is, if I say, what is minus RA? Nothing but, minus dCA by dt. That means disappearance of the concentration. And you see minus sign, this particular graph tells as the time passes by, the concentration of A decreases, right? So this is nothing but change in the concentration divided by the change in the time. Okay. Now, specifically, if we write in general, what we can write as a rate of any order reaction. So here the N denotes the order of the reaction. Of course, can you tell me what is K denote? K denotes as the reaction. What is a rate constant? Reaction rate constant. This is denotes reaction rate constant. Okay, fine. Now, what is that we are interested in? Generally, you see, what is the units of K? K units are concentration power 1 minus N and over time power minus 1. How? See, let me actually put you this into simple parts. I write this as minus dCA by dt is equal to K into CA power N. So this CA power N goes to this place. This becomes dC. I'm leaving aside the minus, CA power N. So this concentration power 1, concentration power 1 N. So this becomes concentration power 1 minus N. Obviously, you have dt in the denominator. So this is divided by time. So this denominator time goes up, it becomes time inverse. So just imagine what will be the units of rate constant in the first order reaction. So if I say on rate constant units for a first order reaction, so I should write concentration power 1 minus 1 time power minus 1. So this is concentration power 0, which is 1 into time inverse, right? So there is a, again, small k. So you can see in this graph, right? This particular graph, this second graph denotes the dependency on of the temperature with respect to k. Arrhenius law you can take, and then you can actually look at. Now the question is, what is the unit of k for the first order reaction? Of course, we have already solved this question. Please comment in. And there are second order reaction, third order reaction. You can actually work out on the units of K, and please comment in the comment box, message in the comment box, so that it will be a continuous learning for you. At the same time, as a motivation to make such more videos to you also in future. Okay, bye.